Welcome to this lesson of an introduction to blockchain and programming in Solidity presented by the Coding Bootcamps. We're looking at a deep dive on Solidity constructs. And we have reviewed this information and reviewed this information. So in our previous lesson, we looked at building a basic contract and all of the constructs and data structures involved in that. Now we're going to look at some other constructs. So mapping types. So mappings are similar to hash tables in that you can build the data structure and you can access them with a key value pair. So we can see here with the customer's mapping is Mark Smith, and Mark's key is right here, and the value happens to be 1. So anytime I want to access Mark, I would just pass the number 1 back to the customer's mapping, and I would get all of the data here that is part of this mapping. And then events are called in order to log special information that we can view in the transaction. It's written to the log. So it's used with also emit to write key information to the log, and the same thing will happen on the blockchain as well. The events will be written to the blockchain. And we can see here in this Solidity contract, we have our mapping, and it's called customers. And if we look down here in this function, we are adding the customer to that mapping. So we can see here this counter is adding a new key value for accessing all of the customers that are being added. And over here, we can see the events and the emits. So when the event is emitted, it will write key information to the log and to the blockchain. The for loop. So with the for loop here, we have the header, and we have the block with our we have our block as well. In this case, we are not using a block because we only have one line, but we would have our curly braces for the blocks. Normally, to define our blocks, we have our initial, where we begin the for loop, how long we loop for, and then the incrementer. So this will increment until we have reached this condition here in the middle. The while loop, so a while will continue to execute the block until the condition in the block header is false. So with the while loop, we have our header and we have the curly braces, and the while loop will execute until this condition here in the header is false. Our do while loops and our while loops are the same, except you can guarantee that the block will execute for the do while loop at least once. And the switch cases works the same way switch cases work for Java, C++, or JavaScript, where it's almost like a simplified if else. The case equal to the value that's returned, and the evaluation ends. And there's no default. The default value is returned when there is no match. So we can see here our do while loop. So this block here will execute one time and then continue while this statement here is true. And we can see here our switch cases here, how it goes in and evaluates, and here is the default line. Error handling. So error handling, there is no try catch in Solidity, at least not yet. But you can enforce some error handling using requires. So with a require, you can require certain values or certain conditions. So in this case, the require returns an error if a parameter returns false when it should be true. So we can require certain values or certain conditions, or else the transaction won't proceed and it'll revert. And the revert function also triggers exceptions and returns an error, and an optional message is passed to the revert to return error details. So the revert we use when we're looking to require a certain condition so our transaction doesn't happen. Because as we all know, with Ethereum, when a transaction completes, a little bit of gas has to be paid to the operators of the blockchain. And if a transaction doesn't happen, we don't want to see our users having to pay that gas for nothing. Here is our exercise. So this is a little long, but it's called My Pay Vendor Contract. And this is kind of interesting because not only do we use what we just learned about to set up vendors, we're actually going to issue just not really a cryptocurrency, but the very, very beginnings of our own type of payment method, which could be considered almost like a currency for our particular contract. And then we're actually going to pay our vendors. So let's take a quick look here at what we'll do for this exercise. I'll demo this. So for this exercise, and bear with me here, we are going to load up the contract called My Pay Vendor Contract. And I have already compiled it, and I have already deployed it. Okay, and here we are right here. So what we want to do here with this one, I'll just run through one iteration of it. Let me clear the console. And we can see here we have our Ethereum accounts, and we're using our simulated Ethereum node called JavaScript VM. So let's add a vendor. And since this is a string, we'll use the double quotes. Maxes, that's what we'll call them for now. And we have to provide Max's Ethereum wallet address. So let's go up here just so we can be consistent and copy it. This is the copy button right here. We can see that we've copied it into the clipboard. We got to be a little careful here. And we just input Max's wallet address. And let's say we owe him 35. It's just 35 for now. And we'll click Transact. And that was successfully mined. And now we are going to, well, now we could add other vendors too, and in your exercise you're going to, but for right now, we'll only go with one. And what we'll do here is, now we will issue, I guess, what we can call a cryptocurrency. So let's go into issue here. And to issue, we have to have an issuing address. So let's grab this address. And let's put 100 in here and issue that amount. Let's go back here, get this address. Okay, it liked that one better. I pasted the wrong address. So now let's look at, with this address still in the buffer, let's look here and get the balance. We can see, ooh, this wallet has 100. That's great. How many vendors do we have? We have one. And what is our issuer balance currently? Oh, I have 100. That's great. And we can see the issuer. Here is the address. Let me clear the console here and let me click the send. Now the send will send 35, because I've already put in 35, the amount of 35 from my wallet to Max's wallet. So let's click the send. And that was successful. Now let's look at my new balance here. Now my issuer balance here is, this is where we get the issuer balance here, is now 65 because I paid 35 out to the vendor. And again, we can look at the vendor information too if we pass in the vendor ID numbers. So go through this and take a look and see the actual steps for completing this this lab. So what I did was I put a vendor address in and I entered an amount that we owe him or her. In this case, it's Max's. And then we filled our wallet with 100, it could be Ether for now. And then we click this button here to actually send 35 over. So that's why our balance now is 65. And this was always our issue balance here, so that's why it still remains at 100, because we issued 100 Ether to this wallet right here, which ends in 733C. Thank you.